guys, if you would please grab out your Simply Similar Unit Assessment Review, and we're going to walk through step by step of each of the questions on our review here. So we're going to start with number 1. Jessica has a rectangular picture, and the picture is similar to a rectangle that measures 4 inches by 6 inches. What could the dimensions of Jessica's picture be? Well, we've learned in previous lessons that the first number is going to be our width and the second number is going to be our height. We can write it as 4/6 of having the width over the height. So the question is asking which could be the dimensions of Jessica's new picture. So we need to figure out which one is going to be proportional to the picture we already have of 4. So what I'm going to do is I'm going to take each of the numbers and I'm going to set up a proportion to see if this is going to be true or not. Now, we know to get from 4 to 8, it's times 2. Well, 4 times 8 is times 2. To be similar, everything has to be times 2. Well, 6 times 2, that does not get me to 10. So I'm going to mark off A. It's not even possible. Let's try letter C. I'm going to start with 4/6 is going to equal 5/7. Well, when I try to go from 4 to 5, or we can sit here and do cross product, 6 times 5 is 30, and 4 times 7 is 28. Well, 30 does not equal to 28, and so that's not possible. So if we can't find a scale factor, we can use cross product and go from there. All right, let's try letter C. I'm going to have 4/6 is equal to 2/3. Well, I know that 2 to 4 is going to be times 2, and 6 to 3 is times 2, so I know that B is a possible choice. And then let's check letter D just in case. 4/6 is equal to 12/14. Well, 4 to 12 is times 3. 6 times 3 is not 14, it is 18, and so D is not a possible answer choice. Leaving the only possible choice here is letter B at 2 inches by 3 inches. All right, number 2, parallelogram PARL. So PARL is similar to parallelogram WXYZ. Which proportion could be used to find the value of C? All right, so I can write 2 separate proportions, and I'm going to go ahead and write my 2 proportions here. I'm going to use 2 methods, one called within and one called between. Within, I'm going to start with 7/15, and 7 is corresponding to C, so I'm going to have C/45. The other option I have to write this, and I'm going to kind of change colors here, is using the between method where I go in between my 2 parallelograms, and I'm going to have 7/C is equal to 15/45. Okay, and now I just need to see which proportion is set up correctly. So let's see, I have 7/15. Okay, that starts. And then I have 45/C. Well, that's not written in the correct direction that we went into, so A is not possible. All right, let's look at letter C. I have 7/C. That's what I started with, so I went 7 to C. To be proportional, I have to start with 15/45. Well, this starts with 45/15, which is not correct. Letter B, I have 7/45. Well, first off, first issue, 7 does not correspond to 45, and 15 does not correspond to C. So B is wrong. Which then leaves letter D, 7/15. That's what I wrote. Then C to 45. And that is our only possible answer choice for our proportion is written correctly. All right. Number 3. The following image shows 4 polygons. Polygons, if you do not know, is 4 or more sided figure. Okay, a polygon is known as a 4 or more sided figure. So we've got 4 different polygons shown below. I want to know which polygons are going to be similar to polygon ABCD and choose all that apply. So it looks like ABCDE is my very first polygon. And to C, I see that they are all the same shape. It looks like my angles are all going to be relatively the same. So now I need to look at my sides, and I'm going to count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 units here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 units here. So I'm going to count all of the sides for each of my 4 polygons. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So I need to see which ones are going to be similar to polygon A, B, C, D. Well, let's go ahead and go here because I know that from 10 to 10 is times 1. Well, in order to be similar, it has to be 10 times 1, and 10 times 1 is not 8. So I need to look for the polygon with K, M, and N. So it looks like K, L, M, N, O is not going to be an answer choice. All right. Let's take a look here. So from 10 to 4, well, we don't have to really know the scale factor. All I know is that I can go from 10 to 4, and I can go from 10 to 4 because it looks like my base and my height is the same number. As long as these two numbers here are going to be the exact same, you don't really have to know what your scale factor is. You just need to know that whatever you're going to multiply this 10 by to get to 4, you're going to multiply the same thing, and you're going to still get 4. So it looks like FGHIJ is a similar figure, and the same concept goes below. Whatever you multiply 10 by to get to 8, you're going to do the same thing to the other 10, and you're going to get another 8. So both of those has to be the same number, and that has to be true. Giving you the only possible answer choices is going to be your little figure of FGHIJ and your other minier figure of PQRST. Those are the only two similar figures to your original A, B, C, D, E. All right, number 4. What 3 characteristics do you know that are true about any similar figures? Well, basically this question right here is asking me what are your 3 rules to be mathematically similar. And your 3 rules are same general shape, corresponding angles are congruent, and then corresponding sides are proportional. Those are your 3 rules to be mathematically similar. Same shape, congruent angles, and sides are proportional. Okay, number 5, 6, 7, and 8, I am all using the exact same rectangle to begin with. So we have a rectangle that is 18 centimeters by 24, and I want to know the similar figures or the dimensions if we were to either shrink it or enlarge it. So reduce or enlarge each of my figures. So I'm going to start with the concept of width to height, or as it is written as width to height. So each of these numbers, if you want to go ahead and write a W and then H above each of these, that might be helpful. Because we're going to set up a couple of proportions here to help us solve these problems. So I'm going to solve number 5 right here. I'm always start with 18 over 24. I always start with what I know. And so I'm always going to write my proportions of width over height. So that's how I'm going to do that. So for number 5, I know the width is 6. I do not know my height, so my height is X. Okay, so I need to find what is my scale factor from 18 to 6. Well, we can think division, and I know that 18 divided by 3 is going to get me to 6. So I need to figure out what is it going to be as a multiplication, and it's going to be times 1/3. And what I do on the top, I'm going to do the same thing on the bottom. So 24 times 1/3, or 24 divided by 3 is going to get me 8. So the height of my new figure is going to be 8 centimeters. All right, number 6, I'm going to still start with 18 over 24. And this time I do not know the width, so that is X, but I do know the height is 3. Well, how do I get from 24 to 3? Well, I know that 3 times 8 gets me to 24. So 24 times 1/8, the reciprocal of that, is going to get me here. And so I need to do the same thing to 18. So 18 times 1/8. So, and it's the same thing as 8 divided by 18. So we're going to go over here, do a little bit of division. Well, 8 can go into 18 at least 2 times because 8 times 2 is 16 to give me 2 left over. Add a decimal, bring down my 0. 8 can go into 20 2 times. 4 left over, add a 0, bring it down. 8 can go into 40 5 times with nothing left over. So the width of this rectangle is 2.25 centimeters. All right, number 7. I'm going to start off again with 18 over 24 is equal to x over 32. So I know that 24 cannot go into 32, but I also can see that 18 and 24 can reduce. So I'm going to go ahead and reduce that number. So 18 and 24 both can reduce by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. And I know 3 over 4 is the smallest it can go. Well, 4 can go into 32 8 times because 4 times 8 is 32, which then means I need to multiply by 8 on the top. And 3 times 8 is 24 to give me 24 centimeters. And then number 8, we're going to still start off with 18 over 24 is equal to 12 over x. Well, I know the same thing. I cannot go 18 to 24, so I'm going to see if I can reduce. And we're going to reduce this again by 6. Not 6, sorry, down here it's 4. To give me 3 over 4. Well, 3 can go into 12 by 4. And to stay proportional, I need to do it by 4 on the bottom. And 4 times 4 is going to give me 16 centimeters. All right, number 9. So number 9 is a map question where Derek lives 13 miles from the shopping center. His map shows that 1/2 inch is equal to 3 miles. How many inches apart is Derek's house from the model, from the shopping center on his map? So this gives me a scale drawing. So I'm dealing with a map, which I need to think of the concept of model over actual to help me solve this. So I'm going to start with what I know, and I know that it's 1/2 of an inch is equal to 3 miles. Well, let's go ahead and turn this 1/2 into a decimal just to make our lives a little easier when we're doing some math. So I'm going to change it to 0.5 because 1 divided by 2 is 0.5. So I'm going to write that. I'm going to write model over actual, or in this case, the inches. So 1/2 inch over 3 miles. And I'm going to set up a proportion. And I know that Derek lives 13.5 miles from the shopping center. And I want to know how many inches is that going to be on my map. So inches is going to be X. Okay, well, we cannot go 3 into 13.5. So what I'm going to do is I'm going to use cross product. And I'm going to multiply 13.5 times 0.5. Now, you do not have to line up your decimals. It just happens to go this way. 5 times 5 is 25. 5 times 3 is 15, plus 2 more is 17. 5 times 1 is 5, plus 1 more is 6. I need to create my decimal place, and I see that I have 2 place values in all. So I'm going to go 1, 2 to give me 6.75. I'm not done here because I still need to divide this by 3. So I'm going to go over here and do 3 divided by 6.75. I'm going to bring my decimal straight up so I don't lose it. 3 can go into 6 exactly 2 times with nothing left over. Bring down the 7. 3 can go into 7 2 times again at 6 with 1 left over. Bring down the 5. 3 can go into 15 5 times with nothing left over. So on his map, it is 2.25 inches on his map. That is how far away he lives from the shopping center. All right, number 10, the Japanese flag has a height to length ratio. So the height is the first number, the length is the second number of 2 to 3. If the Japanese flag is 150 centimeters high, what is the length? So we're going to write a ratio of height over length. And let's start with what we know of 2 is the height and 3 is the length. To create our proportion, we are told that it's 150 centimeters high. So 150 is going to go on top with a length of X. All right, so I need to go from 2 to 150. So I need to figure out how many times can 2 go into 150. So let's go ahead and divide this here. 2 can go into 15 7 times with 1 left over, bring down the 10. 2 can go into 10 5 times with nothing left over, giving me a scale factor of 75. And what I do on top, I must do on bottom. So I'm going to multiply 3 by 75. So 75 times 3. 5 times 3 is 15. 3 times 7 is 21. Plus 1 more is 22. To give me a length of 225 centimeters. All right, number 11, a blueprint has a scale that is 1/4 inch to 1 foot. The blueprint shows the design of the room that is 4.5 inches long to 3 1/4 inches wide. What are the actual dimensions of the room? So it looks like I need to go from the model to the actual. So let's go ahead and set up our ratio, model to actual. And let's go ahead and turn this 1/4 into a decimal. Well, let's think of money, because if I think of 4 quarters equals 1 whole dollar, which is 100, 1 quarter is going to equal 25. So 1/4 is 0.25. So I have 0.25 inches over 1 foot. So I want to know what the actual dimensions of my room are. So I want to know the length and the width. So let's go ahead and I'm going to split this up, and I'm going to go long ways, and then I'm going to do width. And then we're going to set up proportions to solve for both. So let's go ahead and start with our scale factor of 0.25 inch over 1 foot is equal to, well, I know that it's 4.5 inches long, which is 4.5 in decimal over x. All right, so I do not know what 0.25 is into 4.5. So if you do not know that, you can go ahead and use cross product. Well, 1 times 4.5 is 4.5. And then I just need to divide it by 0.25. So let's go ahead and get us some practice here of dividing with some decimals. You cannot divide with decimals on the outside, so you have to move it, and I have to move it twice on the inside and on the outside to give me 450. 25 can go into 45 exactly, or not exactly, but it can only go in there 1 full time to leave me with 0, 2, and 200. 25 can go into 200. I believe it is 8 times. Let me double check. 200 divided by 25 is 8. It can go in there exactly 8 times, giving me 0. And this is 18, which means this is going to be 18 feet long for our dimensions of our room. And then we know that it's 3 1/4 inch wide. So I'm going to start with the same ratio that I have. So 1/4 of an inch to 1 foot is equal to 3.25 inch over x. And I'm going to follow the exact same steps I did here just for the width. So I know that 1 times 3.25 is 3.25. And I'm going to divide it by 0.25 to give me x. So 0.25 is divided by 3.25. You have to move your decimal over, same concept, and bring it straight up. Except this time we do not have to add the 0. 25 into 32 can go in there 1 time. I have to borrow and carry. 12 minus 5, 5, 6, 7 is 7. Bring down the 5. 25 can go into 75 3 full times with nothing left over, giving me 13 feet. So the actual dimensions of the room is 18 feet by 13 feet. There you go. All right, number 12, the figures are similar and determine the missing measures. All right, so the first thing I need to do is I need to list my corresponding sides. Well, I know that AB is corresponding to PO. A to C corresponds to P to R. B to C corresponds to Q to R. So those are my sides that are corresponding. Now I need to list my corresponding angles. Angle A is congruent to angle P. Angle B is congruent to angle Q. Angle C is congruent to angle R. All right, so it is asking me to find the missing measurements, so find the rest of the missing angles and find the missing sides. So let's go ahead and do the angles because the angles are super easy. I want to know what is the angle A. So angle A is here. Well, it looks like I am missing angle A, but I do know that all three angles inside of a triangle add up to be 180. So I'm going to do 64 plus 49. Well, 9 plus 4 is 13. 6 plus 4 is 10, plus 1 more is 11, so that should be 113. So I'm going to subtract this from 180, borrow and carry 7 and 6 to give me 67 degrees for angle A. I need to know what the measurement of angle P is. Well, you just told me that angle A and angle P are congruent, which means P also has to be 76 degrees. I want to know the measurement of angle Q. Well, angle Q corresponds to angle B, and if B is 64, Q has to be 64 degrees. They are congruent, which means equal. All right, I need to know what the side length of A to B is. So I need to figure out what my scale factor is. I know that B to C corresponds to Q to P. So I have to think, how do I get from 23 to 46? Well, I know that 23 times 2 is going to give me 246. So my scale factor from little to big is times 2. So I need to do 19 times 2. 2 times 9 is 18. 2 times 1 is 2, plus 1 more is 3 to give me 38 inches. To be proportional, everything has to be multiplied by the same scale factor. So I'm going to do 22.5 times 2. 5 times 2 is 10. 2 times 2 is 4, plus 1 more is 5. 2 times 2 is 4. 0 placeholder to give me 45 inches. All right, and then number 12 is asking me about the scale factor. So it wants to know the scale factor of PQR to ABC. Well, if I notice that PQR is my little. So we need to remember little to big. My scale factor is going to be greater than 1. And in this case, we already figured out our scale factor is 2. If I'm going from triangle ABC to PQR, I'm going big to little. And this is when my scale factor needs to be less than 1, which means it's going to be written as a fraction. So what I do is I take this number and I'm going to find the reciprocal of this number, which this number can be written as a fraction of 2 over 1. And to find the reciprocal of 2 over 1, you're going to flip the two numbers to give you a scale factor of 1 over 2. So your scale factor from your big, if you're a big triangle down to your little one is 1/2. All right, here we go. And it looks like we are doing the same concept in the next couple of problems. So number 13, I've got two triangles that are similar. Find the missing measurements and the scale factors for each. All right, scale factor from QTR to WYX. So QTR means little. So this looks like it's going little to big, where your scale factor needs to be greater than 1. So let's look at my corresponding side. So it looks like QR corresponds to XY. And so from 5 to 10, I know that my scale factor is going to be 2 because 5 times 2 is 10. Which means if I'm going backwards or in the opposite direction, if I go from big to little, your scale factor needs to be less than 1, which is the reciprocal of 2, which we just learned is 1/2. All right, so let's find the missing sides here. I want to find the missing side of TR. Well, TR is corresponding to Z or YZ. So if from here is times 2, going in this direction, so 20 times the missing side is going to be times 1/2. Well, 20 times 1/2 is going to get me 10. I need to find the missing side X to Z. Well, X to Z corresponds to QR. Well, if I'm going from little to big, I need to do times 2. Well, 13 times 2 is 26. Now I've got to deal with my angles here. I need to find angle T. So let's see. Angle T corresponds to angle Y. And if angle Y is 110, you should know by your rules, angles are equal, congruent. So if Y is 110, T has to be 110 degrees. And then I want to find angle Z. Well, angle Z is corresponding to R. Well, if I know that T is 110, I have to add my two angles up. So 110 plus 50 is 160. And then 180 minus 160 is going to give me 20 degrees. So what is left for angle Z is 20 degrees. All right, number 14, use the diagram below to determine the height of your flagpole. So it looks like this is my shadow method. So I'm going to do height over distance, and we're going to start with the flagpole. So x over 7.5 is equal to 4 over 2.5. Okay, well, I do not know my scaling from 2.5 to 7.5, so I'm going to go ahead and use cross product. So I'm going to do 7.5 times 4. 4 times 5 is 20. 7 times 4 is 28, plus 2 more is 30. One place value to give me 0, or 30. So I'm going to have 30, and I have to divide it by here. So 30 divided by 2.5. So 2.5 on the outside, 30 on the inside. Move your decimal straight over, bring it up, and add you a placeholder of 0. Well, we already did 25 into 200, and we knew that was 8. So every 4 is going to give me 100. So if I have 100 is 4, 200 is 8 times, 300 should be 4, 8 should be 12. To give me 300, which is 0. So the height of your flagpole should be 12 feet. All right, number 15. So it looks like my triangle is flipped over. So I know that DEF is an enlargement of ABC. So I'm going to go ahead and grab a couple of my highlighters here just to help us out and help me out, because we need to highlight a couple of our sides. So I know that AB is going to correspond to FE, because I am told that B is 90 and E is 90. And I know that B and E are on the same, so the top to the bottom is going to be on the same side. BC needs to get highlighted the same color as ED. And then AC is highlighted the same color as FD, as in those are corresponding sides. So let's go ahead and write that. So I know that AB is corresponding to FE. BC corresponds to ED. And then AC corresponds to FD. And then we're going to write our angles. Angle A is congruent to angle F. Angle B is congruent to angle E. Angle C is congruent to angle D. All right, number 16. Jeremy is driving to his friend's house that is 3 inches away from his home. The scale on Jeremy's map is 1/2 inch is equal to 8 miles. What is the actual distance? Okay, so this sounds like a model over actual question again. So I see my scale right here is 1/2 to 8 miles. So I'm going to reduce that 1/2 down to a decimal to give me 0.5 inch over 8 miles is equal to, and I know what it is on my map. I want to know the actual distance. So I want to know how many miles this is going to be. So I can do multiple ways. I'm just going to keep using cross product because I do not know it on top of my head. So I'm going to do 3 times 8, which I know is 24, and I'm going to divide it by 0.5. So 0.5 on the outside, 24 on the inside. Move my decimal over one spot, give me 0. Well, 5 cannot go into 2. It can go into 24 at least 4 times with 4 left over and bring down the 0. 5 can go into 48 times with nothing left over, giving me 0. So in real life, Jeremy's house is 48 miles away. Or Jeremy is 48 miles away from his friend's house. If you can see the scale factor from here to here, that's great. If you do not, then these are the steps to do that. All right, so number 17, the rectangles below are similar. Rectangles E and C are congruent, which means they are equal in size and shape. All right, complete the table for each of the pair, deciding if the scale factor is less than 1, greater than 1, or equal to 1. All right, so I'm going from my rectangle A to B. So I'm going from little to big, which means my scale factor needs to be greater than 1. Going from B to D, so B, so I'm a big rectangle down to a little bit smaller one, but still big to little, it is less than 1. C to E, well, I'm already told that E, C are congruent, so when I go from C to E, they look the exact same, so it's going to be equal to 1. E to A, I go little to big, that's going to give me greater than 1. D to C, big to little, that needs to be less than 1. A to D, little to big, greater than 1. B to C, big to little, less than 1. So if you want to give yourself kind of like a hint here, it is big to little in this one. This one is little to big. If you want to give yourself a little hints and tricks, whatever. All right, number 18, the scale drawing on the map is 4 to 1. If the drawing side length is 10 centimeters long, how long is the actual length going to be? Okay, so even though it doesn't give us anything as far as like, which one is the actual and which one is the model, when you see something like this, it is always going to be used as model to actual. Okay, we learned about this a little bit ago. So I'm going to write a ratio of model over actual, where I'm going to have 4 over 1. And I know that 10 centimeters long, and it's asking me for the actual length. So I know that 10 centimeters is going to be my model. So I'm going to set 10 on top over X, which is what I have that is missing. All right, so I do not know the scaling from 4 to 10, so I'm going to go ahead and use cross product once again. Well, 10 times 1 is 10, and I need to divide this by 4. So I'm going to see how many times 4 can go into 10. It can go into 10 exactly 2 times. With 2 left over, add a decimal and a 0. 4 can go into 25 times, leaving me with nothing left over. So in actual, it is 2.5 centimeters. So it looks like it's really small. All right, number 19, triangle ABC is an enlargement of WXY. And it looks like my triangle has been flipped over. So let's go ahead and grab our highlighters once again. So I see that Z is equivalent to C. So if I go A to C, I went from top to bottom. So I need to go X to Z. Then if I go C to B, I start with this corner. I need to go Z to Y. And then if I do A to B, I need to do X to Y. So let's just go ahead and rewrite our corresponding sides as it is here. So I know that AC corresponds to XZ. CB corresponds to ZY. And AB corresponds to XY. Those are my corresponding sides. Now let's talk about our corresponding angles. Well, I know that C and Z are corresponding, so I know that angle C is equal to angle Z. Based off of looking at this, if I look at my green, I know that A is corresponding to X, so angle A is equal to angle X, which then leaves angle B to equal angle Y. All right, and then one more, number 20. Below is a shape on the grid. I need to create a mathematically similar shape on the grid below by enlarging the original of a scale factor of 2. Start in the bottom left-hand corner. It's been started for you, and remember to enlarge it by 2. Okay, so I need to enlarge everything by 2. So I need to figure out my original sides. So 1, 2, 3. So I have 3, 1, 1, and 1, and then 2. Okay, so I just labeled all of my sides that are going on here. Well, 3 times 2 is going to give me 6, so I need to go up 6. So 1, 2, 3, 4, 5, 6. My width up here is 1, so I need to multiply 1 by 2. Well, 1 by 2 is 2. My base is 2, so I need to make my base over. 2 times 2 is 4, so I need to go 1, 2, 3, 4. I know that all of this is going to be filled in, but I need to figure out this. I have a 1 by 1, so I need to move this over and do 1 times 2. And I believe it's going to look like that. Yeah, 1 times 2 is 2. So this should be 2. This should be 2. That was 2. This should be 4. 1, 2, 3, 4. That is 4. That is 2. That is 6. And that is 4. Perfect. There we go. All right. If you have any questions, please let us know.